All right. So I think you're able to see the screen now. So welcome to the last week of this course. That is week 8 of this course, Python programming. So today we are going to discuss the topic of dynamic programming. So dynamic programming has nothing to do with programming. In fact, it has nothing to do with Python or any programming language. Okay. So in this week we have seen a couple of things. For example, we have seen the problem of grid paths, longest common subsequence, matrix multiplication, and all these we have solved using the technique called dynamic programming. So let me write down. So this is week 8. And in this week, our topic is dynamic programming, which is a technique to solve computational problems. Okay. So it has nothing to do with programming or Python. It's independent of Python. So we are going to see how this technique can be used to solve certain problems. Specifically, today we will see one specific problem, which is part of our programming assignment. So I will go to that problem, but I will also describe what is dynamic programming briefly. All right, so I'm not going to look at the problem immediately. So if you're given a problem, okay, let me give you a concrete problem. So let me give you a concrete problem. So I give an array, input is an array A, let us say of n numbers. Let us say integers to be precise. So I'm going to give you n integers and I want you to find the maximum integer in the array A. Okay. So how do you solve this problem? What are the steps?
You need to scan each element of the integer and find the maximum.
Yeah, that is one sentence answer. That is good enough. So how we do it, we have seen. Let me take some concrete numbers. 6, 9. I mean, what is the best way to? I'll just take comma separated. That is better. Maybe, yeah, let's say not too many. Let's say so many numbers are sufficient. Okay. So I give you array A. So this is A. So let me. So this is array or list, doesn't matter. So conceptually, how we go is the following. We say that, okay, let us suppose that the maximum element is at the beginning. The first element of the array itself is the maximum element. So we suppose that max is, so the way we write the program, we say that max is 6, suppose to start with, and then we run a for loop. Then we run a for loop and we check whether the next element is greater than the max that we have seen so far. Okay, so for example, in the loop, what will happen when we see 9? When we see 9, we will update max to, we will say, okay, 6 and 9 are compared. So 9 is greater than 6. So I am going to update max from 6 to 9. Next iteration, what I'm going to do, I'm going to compare the present max. So this max is no more there. This max is no more there. So the present max, I'm going to compare it with the next number, which is 11. And I'm going to update the max from 9 to 11 and so on. Okay. So this is the algorithm, but we can think of this algorithm in a slightly different way. So what we will do is we will say that, okay, this is my problem. I am going to divide this problem into a sub problem, and then I will solve the subproblem and do something else which will solve the full problem. Okay, so I'll give you a diagram. So I have a problem P, let us say. So here is my problem P. I'm going to make it large. So I'm going to break down P. So I'm going to break down P into a subproblem P1, and maybe I'll not make it so abstract. Uh, so let me just keep it simple. I'm going to solve for the n minus 1 numbers first. This is my first step. Second step, solve for the next number. So I will solve the problem in 2 steps. So the first step is to find the maximum of the first n minus 1 numbers. So the last element, I forget about it. I ask myself that what is the maximum integer for the first n minus 1 numbers. And if somebody gives me the maximum for the first n minus 1 numbers, in the next step, I compare that maximum with the nth number and I have the solution. So find max for the n minus 1 numbers first, and then compare. So let's say that is max, and then compare max with, let us say, the nth number. So nth number in array notation is k of n minus 1. So okay. So this is just a way to think. So what I'm doing, there is a fundamental difference. The difference is that I prefer to think the problem in terms of subproblems. So if somebody gives me a solution to the subproblem, using that solution, I am going to I'm going to construct the solution to the problem. Okay. So in this example, if somebody tells me that so far in the first 5 numbers, the maximum is 11. So I am just left with the job of comparing 11 to 5. And then I get the maximum number. Okay, so this is the crux of dynamic programming. First, you divide it into subproblems, which gives you some solutions. And from the solutions of the subproblems, you construct the solution to the full problem. All right. So is the concept of dynamic programming clear?
Yes.
Okay. Okay. There's a mistake here. Okay. So now that we understand dynamic programming is about, so there are 2 more properties I have to tell you before I move forward to the question. So 2 more things I will tell you. One is called the optimal substructure property. Okay. So what is the optimal substructure property of the problem at hand, of the problem that we are considering? So this says that it is possible. So this property, what does this property say? So this property says that, so we are going to use dynamic programming only in those cases where the optimal substructure property holds. If the optimal substructure property does not hold, then we cannot apply the technique of dynamic programming for the problem at hand. So the optimal substructure property says that it is possible to find a method. Is it? Please keep yourself muted unless you want to talk. So the optimal substructure property says that it is possible to find a relationship between the optimal solution and the optimal solution of the subproblems. So the optimal solution of the subproblems is related to the optimal solution of the original problem, the full problem, in some precise way. Okay, so I'll write it down. Although I'm being informal here. So the optimal solution to the full problem can be constructed from the optimal solution to the subproblems. Yeah. So consider the problem that we gave as an example, this problem, that finding the maximum in an array. So we saw that it is possible to find the maximum of the whole array by comparing the maximum of the first n minus 1 numbers, that means the solution, the optimal solution of the subproblem, with the nth number. So there is a precise relation in which the optimal solution of the full problem is related to the optimal solution of the subproblems. Okay. So this is the optimal substructure property. Okay. So far so good. Any questions on the optimal substructure property?
No, sir.
Can you please repeat once again?
Okay. Let me try to make it simpler. So you have a problem, and you don't want to solve the problem in one go. Rather, you want to divide the problem into pieces. Okay. So, for example, if you want to cook a dish, you cannot cook it at one go. You have multiple steps and multiple things. For example, you may have to boil certain things, you may have to fry certain things, and then you may have to mix these things together, right? So boiling certain things and frying certain things, these two things can be done independently. But to do the best possible cooking, you may have to do the best possible boiling and the best possible frying. So the optimal cooking would be a function of the optimal boiling and the optimum frying, and as well as the optimal mixing. Okay, so think of it this way. So to find the optimal solution to the problem, you need to find the optimal solutions to the subproblems. And once you have the optimal solutions to the subproblems, there is some way you can use these solutions to construct the solution of the full problem, that is the cooking problem. All right.
Okay.
So here, the simplest question that I asked you to start with is find the maximum in an array. Now the array has, let us say, n numbers. So then you ask that, okay, can I know what is the maximum integer in the first n minus 1 elements of the array? If somebody gives you the optimal solution to this subproblem of finding the maximum in the first n minus 1 numbers, then you can use that solution and compare it with the nth number. In this case, you compare 5 with the maximum in the remaining. So the maximum in the remaining is 11. So if somebody says that 11 is the maximum you can get if you don't consider the last number, so you know that I can compare the maximum 11 with the last number 5 and give you the maximum for the entire array. So it is very important to be able to precisely define the relation of the optimal solution to the optimal solutions of the subproblems. Then only you can apply the dynamic programming. So that is the optimal substructure property. Okay. Fine. Yeah. So why are we interested in dynamic programming? So it turns out that uh, in many settings, uh, it helps a lot to think of the problem into subproblems. It helps a lot uh, to divide a problem into subproblems and then solve the subproblems optimally, and then somehow construct the optimal solution from the solutions of the subproblems. In many settings, this helps. Uh, for example, let me give you another concrete question. Suppose I give you a set of line segments. So what are line segments? So line segments are uh, straight line connections between 2 points on the plane. Okay. So a line segment is uh, represented by its endpoints. For example, I can say that this line segment, this is one line segment. Okay, let me make it red. Why is it not red? I chose red. Oh, this is text. All right. So for example, this line segment is represented by its two endpoints. So these two endpoints have certain coordinates, x coordinate and y coordinate, and it is possible to describe a line segment by providing the coordinates of the endpoints. So if I give you uh, the description of n line segments and ask you how many intersections are there, uh, then what would you do? What would be the algorithm to find all the intersections, all the points of intersections among a given set of n line segments? So what algorithm shall you employ?
We need to check the individual line segment separately and need to compare with the existing line whether it is coinciding individually, and then we can find how many intersections happen.
Coinciding meaning?
Intersection, I mean.
Okay. All right.
Pick up a set, probably starting point, and then compare it with the other sets to find out the intersection is there or not.
Okay. You mean when you say set, do you mean a line segment?
Yes, pick up a
Okay.
line segment starting one intersection, probably a starting point, and then compare it with the rest of the other
Yes.
lines.
That is the easiest thing to do. That you start with a line segment and check whether this line segment is intersecting the remaining line segment. So for every line segment, you have to check with every other line segment. And there is a high school algorithm that lets you check whether two given line segments intersect or not. So this is a brute force algorithm that you start with a line segment, and or rather you decide some ordering of the line segments, and for every segment you check whether the remaining segments intersect it or not. So you will be able to identify all the points of intersection. For example, this line segment is intersecting one, two, three line segments that you will be able to report at the end of processing this line segment. And then maybe you start with this, you proceed to the next line segment and so on. So this is going to take, okay, so this is going to take let us say the n line segment. So how much time will it take?
based on the number of line segments.
Yes, based on n, how much time will it take? Order n. That is, Shanmugh is saying order n. Kahan is saying order n squared.
N square.
Yes, why n squared?
Comparing it.
Quadratic, no? Basically, it's a quadratic.
Yes, why is it quadratic?
X and Y, two are there. Two
That
quadrants.
is not the reason. The reason is what Kajal was saying. Kajal, I think.
You are going to compare that whole thing, right? So probably you are going to check every point of time, and it will take an iteration, it will take a loop to do that.
Yes, yes, yes. So there are two loops. Okay. So for every segment, you have to compare with every other segment. So for a segment, there are n minus 1 comparisons to be made. For the next segment, again, there are n minus 1 comparisons to be made. For the next segment, again, there are n minus 1 comparisons to be made. So overall, there are n segments. So n into n minus 1 would be roughly the amount of time that you will need. So n into n minus 1 is quadratic. So Gahan is saying that check each line with each other. So that is even more precise. So you have to check for every pair of line segments. So how many pairs are there? N choose 2 pairs are there. So n choose 2 is n into n minus 1 divided by 2. So that much time you will take. That much time you will take. Now think of this problem as a dynamic programming problem. So you order the lines in some order. So what does ordering mean? So you give some number into every line segment. So for example, let us say I give a left to right ordering in terms of the left endpoints of the segment. So I say that okay, this segment is uh, segment 1, this segment is segment 2, this segment is segment 3, and so on. So I give an indexing. I give an indexing to the line segments, and then I ask that can I use dynamic programming to solve this problem?
Can we solve it like dividing into quadrants and then the line segments which are there in the quadrants?
Yes. Who is that?
Vinaya.
All right. This is good suggestion. So Vinay is saying that can we do divide and conquer? Can we do divide and conquer? So she's saying that think of some origin and some x-axis and y-axis. And when you have this coordinate system based on this x-axis and y-axis, then the entire plane is divided. The entire plane is divided into 4 quadrants. And she's saying that, okay, can I do divide and conquer? That I will count the intersections that are present in quadrant 1 separately. I'll count the intersections that are present in quadrant 2 separately, and so on, and then I will merge. So that is a divide and conquer approach. I mean, that is also possible, but more details are required. So you can give it a thought whether it. So yeah, of course, this is a valid approach. Again, what I am asking is that can we use or can we think of this problem in terms of dynamic program? So one can also think of it as DP, but which one we will think, which one will work in the best interest of the programmer depends on the running time of the program, that how much time the algorithm will take. Okay, so if the running time is quadratic in both cases, then we can choose one arbitrarily. But if somebody gives an algorithm whose running time is n log n, which is better than n squared, then we will choose that algorithm. That is a overall, or even linear is even better, ordering is even better. That is the overall thought process of the programmer. Okay, so one can do divide and conquer. I will not go into the details. You can think about it. But what is the best way to think of this problem in terms of subproblems and then utilize the solutions of the subproblems to get the optimal solution to the problem? So how can we use DP?
One line can intersect multiple lines. So probably, giving line a number to find out whether they are intersecting with multiple lines, that will be a solution.
Okay. So one line can definitely intersect multiple lines. So see, I will use the word segment instead of line. So line means both ends are at infinity, and segment means the endpoints are finite. So when I say segment, I'm thinking about something like this. When I say line, I'm thinking about endpoints at infinity. So a line is always containing the segments. Okay. So one segment can contain intersect many other segments. That is true. Uh, but to be able to think of an algorithm which is a dynamic programming algorithm, I will have to first define a subproblem. So right now the problem consists of n segments. The input consists of n segments, and I'm asking that how many points of intersection are there. So I'm asking that how many pairs of segments have intersected. So how do I think of the subproblem to start with?
First, we need to consider one line segment first.
Yes. One line segment, it is not going to intersect. I mean, oh, you mean,
Sorry, I mean two.
okay, this is valid. So one way to think of the subproblem is start with two line segments. Okay. And then you check whether these two line segments intersect or not. And then whether, depending on whether they intersect, uh, uh, you can either add 1 or 0 to your final answer. So two line segments can have at most one intersection. So two line segments can contribute either 1 or 0 to your final answer. That is a valid way of thinking about subproblems. But I'll give you another way of thinking. So I have n line segments. So I arbitrarily choose one line segment and I forget about it. So I delete it. It's no more there. And then I ask that again, what is the total number of points of intersection out of these remaining n minus 1 line segments? Okay. So let us say that I denote, I have to go to some more white space. So I denote by sol, sorry, just a second. I have to make it larger. Yeah. I denote by sol I the number of, okay, this is just a, okay, this is not an array. Okay, let me make it. So I'm saying sol sub I denotes the number of points of intersection when we restrict our attention, that is when considering the I, rather in the, so we have an indexing the first I segments. All right. So what do, Okay, so this is for the purpose of notation. So I have defined a notation. So I'm saying that by sol sub I is a variable. I denote the number of points of intersection when considering the first I segments. Forget about the remaining n minus I segments. Okay. So the notation is sol I. So then if somebody gives me sol, just a second, make space. If somebody gives me sol n minus 1, that if somebody says that, okay, so then so segment that I have deleted, let us say that is the nth. Or maybe I will not delete this. I will delete that segment, which is yeah, maybe I will delete this one. So this segment I'm going to delete. So I'm going to just give it a different color, or maybe I'm going to make it dashed. So I've deleted this segment. This is the nth segment, and removing this segment leaves us with n minus 1 segments. And somebody is telling us that if you consider these n minus 1 segments, then sol n minus 1 is the number of points of intersection. If somebody gives us this information upfront, then how are we going to find sol I? So what sol n? So what is sol n? Sol n is the final solution that we are looking for. That is the total number of intersections. So with this information upfront, that sol n minus 1 is some number. Somebody has already told us that there are so many intersections with the first n minus 1 segments. Then how shall we find sol n from sol n minus 1?
You need to just add whether the how many intersection has nth item, nth line segment has.
Yes. So we just have to check that this nth line segment is involved in intersecting how many line segments. For example, in this figure, we can see that only one line segment is being intersected by the nth line segment. So what I will do is I will be able to define a relationship between sol n and sol n minus 1. So sol n minus 1 is already there. That many intersections we already know are coming from the already existing n minus 1 segments, plus additionally certain more things. In this case, only one intersection that involves the nth segment we have to count. So this way we have been able to establish a relationship of our final solution, that is a final optimal solution, with an optimal solution that we have already calculated or known. So, okay. All right. So we have established what is called the optimal substructure property for the problem. Now, the second important thing is to be able to do the second part. That means now the second part was, identifying this nth segment intersects how many other segments. So that part, which is responsible for sort of merging the solution n minus 1 with 1 to get sol n. So that is a second part. So first part is to solve the subproblem, that is sol n minus 1, and the second part is the merging step. So in any dynamic program you will ever see in your life, there will be two parts. One is solving the subproblems, the other is merging the solutions to the subproblems. In this case, the merging step was just checking the last segment intersects how many other segments. All right. Any questions, any doubts on how dynamic program works?
This solution for n minus 1 also will be again subdivided. It will be broken down for.
Yes, very right. So if sol n minus 1 can be written in terms of sol n minus 2 and so on. So at some point we will hit the base case, which you said, which Krishna said, that when we have the base case, that is we have only one segment. When you are looking at the first, I'm going to write down what is sol 1. Sol 1 is the number of intersections you have when you have considered only the first segment. So that is the base case. So you hit the base case. We say that we are hitting the base case, and base cases are generally trivial. In this case, what is the value of sol 1? Considering the first segment only, deleting every other segment, only looking at the first segment, and other segments have vanished, how many intersections could be there? The other segments are part of the input, but we are not considering them at all. So definition of sol I, please read the definition of sol I. This is the number of points of intersection when considering only the first I segments and deleting everything else. Then what is sol of 1? There's no
2.
other segment at all.
0.
Exactly. There is no other segment. Sol of 1 is 0 because there is no other segment. We are considering nothing else.
Okay.
So this way, we will be able to construct the full solution. Okay. So this is what is called the top-down approach, that you get sol n from sol n minus 1, and you get sol n minus 1 from sol n minus 2, and so on. Finally, you get sol 1. But if you do top-down, then something called the problem of overlapping subproblems will arise. Okay. So I will not go into details, but there is something called the problem of overlapping subproblems, which we will like to avoid. So the way to get rid of this overlapping subproblems problem issue, I'm going to call it issue, the way is to implement in a bottom-up fashion. So we'll write programs in bottom-up fashion only. So we'll write a program today and we will see how to do that. All right. Okay, so I think I have to make more space. I'm not going to go into this. Yeah, go ahead.
Sir, how does the overlapping subproblems issue occurs?
Have you? Okay, then I'll give you an example. So I think, I don't know whether the Fibonacci problem, the Fibonacci numbers computation was discussed in the course.
Yes, discussed.
Okay. Okay. So I think it must have been discussed how we are going to hit the overlapping subproblems issue when computing Fibonacci numbers. But still, I will try to let me think. Can I give you a simpler example? I'll give you an even simpler example. Okay. So I am going to give you a simpler problem. So my question is find n factorial. So I'll give you input. Input is an integer n. Okay. And your objective is to find n factorial. So this is a toy problem I'm going to tell you just to illustrate the problem of overlapping subproblems. Or maybe the Fibonacci thing will work out better. Let me talk about Fibonacci only. So I'll give you an integer n, and I want you to find Fibonacci of n. Okay. So what is the definition of Fibonacci numbers? Anybody?
addition of previous two integers.
Yes. So the definition is there is a base case. So Fibonacci 1 is 1. I think Fibonacci 0 also exists. I don't know. It depends on the convention. Let us say Fibonacci 0 is also 1. Fibonacci 2 is also 1. So the first Fibonacci number is 1. And sorry, the 0th Fibonacci number is 1. And the first Fibonacci number is also 1. And the subsequent Fibonacci numbers are defined in terms of the previous Fibonacci numbers. So Fibonacci, these are the base cases. So these are called the base cases. Okay. And now here is the inductive. So definition is inductive. There's an inductive definition. So fib of I is fib of I minus 1 plus fib of I minus 2. Okay. So with this definition, all other Fibonacci numbers can be computed, isn't it? What is Fibonacci of 2?
Fibonacci of 1 plus Fibonacci of 0. That is 1.
No, let us say both are 1, 1. Let us say, I don't know. It depends on the I don't know what is the convention. Let us say Fibonacci 0 is 1. Let me check what is the convention.
No, in the lectures also it came same way. The base case for fib 0 and fib 1, both they consider 1 only.
On only, no, fine. Then it's fine. All right. So this way you understand that it is possible to obtain all the Fibonacci numbers. So now if somebody asks you to find the nth Fibonacci number or ith Fibonacci number, okay, then one can use dynamic programming. So you can say that, okay, I already know from this relationship because it's an inductive definition that if somebody tells me the I minus 1th Fibonacci number and the I minus 2th Fibonacci number, then I can immediately do one addition and obtain the ith Fibonacci number. So basically two sub problems I can merge to obtain the uh, bigger problem, or solutions to two sub problems can be merged to obtain the solution to the bigger problem. Now what will happen is that uh, overlapping subproblems will arise. How it will arise, I will show you with the help of a diagram. So let us say I draw a tree. Okay, so this is a root of the tree. This node is root of the tree. This is corresponding to Fibonacci I. Okay, so it is saying that, okay, so you know that to obtain Fibonacci I, you have dependence on Fibonacci I minus 1 and Fibonacci I minus 2. So because you have dependence on these two nodes, I am going to show these two nodes as the child of this root node. So I'm going to draw a tree and I'm describing to you that what are the nodes and what are the edges in the tree. With the help of this tree, I will demonstrate how the problem of overlapping subproblem arises. So Fibonacci I is dependent on I minus 1 and I minus 2. Again, Fibonacci I minus 1 is dependent on Fibonacci I minus 2 and Fibonacci I minus 3, the previous two entries. So I'm going to draw these two children from I minus 1. Okay. And so on. So you can understand what I'm going to do. So observe that I minus 3 is a node which is a child of I minus 1, but this will also be a node as a child of I minus 2. So I minus 3 gets repeated because I minus 2 is also dependent on I minus 3. So you can see that there is repeated dependence And thus, if you go naively, recursively, then you have to compute the same Fibonacci number again and again. For example, I minus 4 will be part of, so I minus 4 will occur as a child of I minus 3 also. It will also occur here also. And so you have to continuously recompute something that you have already computed. That is why we call it the overlapping subproblems issue. Is that all right to whoever asked the question?
Yes, sir, it's all right.
Okay. So whenever we deal with dynamic programming and we set up a relationship between the solution to the final problem and the solution to the subproblem, we may, in many cases, encounter the overlapping subproblems issue. Okay. But we can avoid that issue. In fact, there is a simple workaround that we implement the program, the solution in a bottom-up way. That we do not solve n-1 first. We start from the base case and slowly we build up to the larger subproblems. We start from the smallest subproblem and we solve it, and slowly we solve for the bigger subproblems. That is the way to go for dynamic program. So now I have told you how dynamic program works with the help of certain examples. So at this point, we are ready to look at the question of the week that we are going to solve. Okay. So I'll show you the question, but before that, any other questions?
Hello, good evening, Siddharth. This is Vinaya here.
Yes.
I know this is a doubt clearing session, but I wanted some information on how the exam will be, like what kind of problems will be there and what kind of preparation, how much will be the weightage, how will it be distributed, some light on the examination pattern.
Okay. So the examination is going to be conducted by NPTEL, and I have no say on the examination. I have no clue what kind of questions will be asked and what is the pattern of the exam. But if there is any student who has taken this exam before in the last offering or some other NPTEL course, please feel free to unmute yourself and give your opinion on this. It can help others.
Or you can direct where I can get information on what will be the format of the question paper, distribution of marks, like on the weeks we have learned.
I have no clue whom to contact. So there is a NPTEL email ID, which many people told me that uh, emails are not responded to.
Yeah.
So I don't know what to do in such situations and how to get information. But if somebody who has experience, prior experience, he or she may help us out in this matter.
I've not written the exam before, but from the websites and YouTube, I checked those who have already written. They have shared their experience. Based on that, I can tell.
Okay.
It will be all are like multiple choice questions, and it will be like in the quiz questions what they ask. No, it will be similar to that. That's what they have mentioned. There won't be any programming kind of things, but it will be like in the quiz there are questions. No, it will be similar questions may come. That's the experience they have shared.
All
So
right.
the question mark size will be something 2.5 or something, not like 50 marks for a program or something.
No, yeah,
Can you
similar
clarify
only.
that?
Maybe 2.5 or 2, maybe very based on individual question, not like a big assignment sort of
Okay.
question.
Okay, okay. That was my primary concern. Thank you so much.
Thank you for the question, Vinaya, and thank you for the answer, Krishna.
So I'm
I
Sadhu.
have Sorry,
just have
sir.
to
Just
add something to this.
just would like to add to it. If you log into your account and go to your course outline, you will find out how does NPTEL online courses work. Under that, you will find videos of explaining how the exam format is, how the weightage is going to be given to each assignment and questions. So there are separate sections and videos on it. You can refer to that.
All right.
Thank you,
That,
Kajal.
yes, there was one more person wanting to add something.
Yes, I just had to add something to the question that Vinay asked. That will there be any MCQ types questions, or will the test completely be some like a coding test, like 2 marks for each code? Like because that I have seen the outline completely, and this is not mentioned in the course outline thing. Like for example, 30 marks out of 70 would be for MCQs, and 35 or something like that for writing the code or something.
Okay, so you are asking this question. So if I understand correctly, then Krishna has ruled out the possibility of large coding assignments. There could be small coding questions like, okay, so this is a code and what would be the correct line, correct programming code snippet in this line that might carry 2.5 marks or something. That is what I understand from what Krishna said.
Yes, sir.
Okay.
So what has happened in the past may not repeat in the future. I do not know, but we are talking in terms of past experience only here. Uh, I don't know if it is possible for you to mail the instructor. You can also try to mail the instructor. He might be able to help, because if you're not getting responses from NPTEL, that could be one option.
Because you know what, I had a specific problem in week 5 or something. I did complete the programming assignment, and the difference was a very small difference. Like the expected output was 0.00 and my output was zero point 0, and the assignment was evaluated like 0 and 100, so 0 exactly.
Okay.
So that's what made me ask this question, ki how will the question format be? Because if it's going to be
Okay.
automated testing, then will there be any weightage given to the logic which is written?
I cannot answer that question because I have no clue, but I understand your concern. It's a valid concern because so many people are going to take the tests. I checked that
Yeah,
there are
and
many.
this is not shared in the outlines or anywhere. And I did write a mail and I didn't get help on that also.
Okay. Okay. So my responsibility in this course is limited to conducting the problem solving sessions.
Okay, thank you.
I,
Yeah.
yeah, but it is, I would also be equally concerned and helpless if I were in your shoes. But there's not much I can do to help you. You have to try contact the people who are going to conduct the exam. If it doesn't work, then I don't know what is the right thing to do.
Excuse me, sir.
Yes, please go ahead.
Sir, when I searched in Google and YouTube, there is no such a long program we have to write. They already given the program snippets, and we have to. Someone told their experience, past experience like that. He's having. He had three sections, and one section like our quizzes and programs, programming. Assignments we had in our course like that. Some differences are there, so we have to give numeric answers list, our output as a list string like that. In section 2 he said fill in the blanks. They given the some programs, so we have to give what the next step we have to write like that. Some single step we have to write. And third section Maybe they are asking more about the stacks, heaps, queues, binary search trees, and list and string manipulation like that only. No such a long program he had not written that time.
Okay. So I think it is quite, I mean, natural to not have long programs because the evaluation also gets tricky.
And
Sometimes programs
only
are,
we have 3 hour time is there. So I think there is no long programs will be we have to write. And we want only equal to in 100 we only need 40 marks to get a certificate, more
okay.
than 40 marks, and it will convert to 70 75, and then they will add up to the assignment scores.
I didn't get you. So if, what is the weightage of the assignment?
25.
Okay.
Then the exam will be in 100, then our mark will be converted to 75 out of
Oh, okay, okay.
75, then
I see.
75 will be added to assignment 25, then we will get a certificate out of 100.
Okay, okay. So the programs, I mean, the assignments are 25% and the exam is 75%. And taking these two things together, you should get at least 40% marks to be eligible to get the certificate.
Yes, sir.
Okay. Okay, that was a good amount of information about the exam and about the evaluation.
Sir, I also shared one YouTube video. There they have explained the question pattern, how it will be. But
Oh, okay, okay.
it's purely past. We don't know. Same will continue for this semester also. If we are lucky, it may continue also.
But I think on matters of this automated evaluation, when the evaluator is expecting something very precise, you should read the instruction very carefully during the exam, that what is expected in the answers, so that you do not make silly mistakes or you don't write something which is unexpected, which is not in the protocol. So Monish is asking, please, can you explain what exactly the bottom up way mean once again? Yeah, we are going to see what is bottom up. So we are going to write a program and we are going to see what is the meaning of bottom up implementation, so that we can get around the overlapping subproblems issue. So all right, so at this point we can take a break, but I will show you the question that we are going to solve based on what we have discussed today. Okay, so actually, yeah, I mean, I will copy this question. So I will show you this question here. The remaining part of the question I will copy and paste in the chat. I will just do one thing. So the input format and output format is what I will want to copy. So we will get enough time, minimum 10 minutes to read. So I'm going to copy this, put in the chat box. Mr. Sham Sundar saying that sometime program will be given and we have to write the output. Yeah, the output could also be asked. Here is the sample input. And here is a sample output. Output is 24. Okay, so now I will let you read the question for about 10 minutes. We can be back after 10 minutes and we can write the program for this question. So I hope that you had a chance to read the question. So is the question clear? Am I audible?
Yes, sir.
Yes, sir.
Okay. So is the question not clear?
Question is clear, sir.
Okay. Is there anybody who needs more explanation about the question?
That is solution int they are given, no, so that can you explain?
Yeah. So we'll focus on the hint. So basically, the input is an array. The input is an array. The array could have positive as well as negative numbers. The question is, what is the expectation? The output is a single number. What is the input? So the input says that the input is n comma k, where n is the number of tests for which marks will be provided. So in this case, these numbers are to be thought of as marks in tests. How many tests are there? In this case, we can see 1, 2, 3, 4, 5 plus another 5, 10 tests have taken place. So a person has got marks, so many marks in these tests, and that is n equals to 10 in this case. What is k? K is the limit of how many entries may be dropped from a segment. So in case k is equal to 0, the question is what is the best consecutive performance of the student? So they're saying that if you consider the tests 5 to 7, then that yields a total of 15 marks. So 5 to 7, if you consider, fifth test 6 marks, sixth tests minus 1, and seventh test 10. So total sum is 6 plus minus 1 plus 10, that is 15 marks. So if you consider the best consecutive performance, that means no drops in between, then 15 marks this person has got. But if you're allowed to drop 2 tests in a segment, then they're saying that 1 to 7 is the best, while dropping the tests 2 and 4. So if you look at the tests from 1 to 7 and you do not consider the marks for test 2 and test 4. So test 2, the person has got negative marks, minus 5. Test 4 also, she has got minus 7. So forget these two. We are allowed to drop at most 2 test marks. So the remaining things, how much she has got? 6 plus 3, 9, plus 6, 15, minus 1 is 14, plus 10, 24. Okay, so 24 marks is the best one could get from the performance of the student, while being allowed to drop 2 test marks. So k is the number which denotes how many tests can be dropped. Okay, so if many tests could be dropped, for example, if she is allowed to drop up to 6 tests in a segment, then the best total is obtained by taking the entire list and dropping the 5 negative entries to get a total of 33. So she has got 5 negative marks. Forget the 5 negative marks. We are allowed to drop at most 6 tests when k is 6. Then she has got 6 plus 3, all the positive things. These positive things, as they're claiming, sum up to 33. Okay, so now given that n and k, you have to tell that what is the best sequence of marks while being allowed to drop k tests. Okay. Now we'll look at the hint. So they're saying that we are going to do a dynamic program and we have to be able, yeah, go ahead.
Yeah, this length of the segment is not defined. It can be anything.
Yes.
Uh,
As long as you
shouldn't
do
the
not,
length of the segment be decided? At least like the minimum length or something like that?
so your input is this set of marks, in this case 10 marks, as well as how many tests can be dropped. So that k, value of k. For example, if the value of k is 2, value of k is 2 means the best you could do is to pick this segment 1 to 7.
Yeah, but they're
So
continuous.
yes,
So
the
1 to
segment
7,
is
but 8,
continuous.
9,
This,
10 we are not considering at all in that case.
because if you consider 8, 9, then you have a lost situation, right? 1 to 7, if you take the sum without taking -5 and -1, then you are getting a total of 24 marks. Now, if you take 8 and 9 as well, then you are losing
16.
minus, yes. So your objective is to maximize the sum of the segment while having the liberty to drop at most 2 tests.
Okay, we just take it because it is defined like that.
No, it is well defined. So what is the length of the segment is going to be dictated by how many tests you can drop. So that is implied by that. So, okay, so let's do one thing.
No,
Let's
suppose if
discuss.
I take a segment 10, I have got all the negatives, and I take a segment of only one length, that is 10, which is 8. So will that be a one? I can drop 2. So there's nothing as 2 which I can drop, right? My segment length is only 1.
That is sufficient. That is a valid solution, but that is not the optimal solution.
Okay, but that's a valid solution.
That's a valid solution, but your objective is to find the optimal solution. That is the best solution.
Okay. No, I was considering that all the marks are negative and only one is positive, and then I select only one to get an
That is the
optimal.
best solution. If all the marks are negative except one,
Yeah,
then in any situation you will prefer to take that positive marks.
yeah. So can I take a segment as only length 1?
You can.
Okay, okay.
Fine.
Thank you.
So the question is, so in this question you have to first think that can I use dynamic programming? And if I have to use dynamic programming, then I have to establish the optimal substructure property as the first thing. And there is a good chance that there could be this overlapping subproblems issue. Ramaswamy Kannan. I have muted him. All right. Yes. So the hint is basically pointing towards how to establish the relationship between the solution of a subproblem and the solution of the full problem. So the hint is basically saying that how to uh, implement the DP, how to implement the dynamic program. So I will give you 2 more minutes to just focus on the hint. So it says that I'm going to define some notation. So the notation is best I comma, let me make it bigger. So I'm going to focus on the hint only. So what is the notation? Notation is best I comma j or best ij, where I is varying from 1 to n, that is all the test scores, and j is varying from 1 to k, that is all the possible number of drops you can have. So what does best ij mean? It means the maximum segment ending at position I with at most j marks dropped. Okay. So what does it mean? It says that, okay, I am not going to take any test scores beyond the ith test, and I am going to take the segment such that the ith test score is the last score that I'm taking. So you have to take a set of consecutive tests scores, but you are allowed to drop certain things. That's a different issue. But you start somewhere and you end somewhere. So they're saying that if you end with the ith test score and you drop at most j marks, then the best possible thing that you could do is stored in best I comma j. So this is basically defining what is the subproblem. All right. So many subproblems are already defined. So how many subproblems are defined? N times k subproblems are defined. For every value of I and every value of j, there is an entry best I comma j. So that is a subproblem. So many subproblems are defined. Okay. Now, from these subproblems, how do you get the problem? I mean, from the solutions of the subproblems, how do you get the optimal solution to the full problem? So one of these entries in the best matrix. So since best I comma j is a matrix of size n by k, so one of these entries in this matrix is corresponding to the optimal solution for the full problem. What is that entry in the matrix?
Is it for I equal to 1 and j 0?
So I equals to 1 means you are not.
Your starting position.
No, it's the ending position. Denote the maximum segment ending at position I.
Oh, okay.
Let me discuss this in more detail. I think people are not getting it. There is no point going forward if people are not getting it. Of course, there is no point writing the program if the concept is not understood. We'll start with a blank slate again. We'll try to understand how to define the DP. So we have seen the DP for a very simple thing as uh, uh, finding the max in an array. So this is slightly more difficult. So these are the marks. How many marks are there? There are n marks. So these are the marks, right? So this is the mark for test 1, test 2, test 3, and so on. So I will also write down the input. So n is the number of tests. So there are 10 tests. And let us say that k is equal to 2. That means 2 tests can be dropped. This is the array. Okay, now I will write down the hint also. So for n between I between 1 and n, j between 1 and k. Okay. for I between 1 and n, and j between 1 and k, what do we have in the hint? We have the following. These are hint. So from the hint, how shall we realize that how to design the dynamic program? Okay. So my first question that I asked you is that which best I comma j entry is the optimal solution? So what is the optimal solution? Is the maximum subsegment while being able to drop uh, two test scores. So imagine this table. So imagine the best array, which I'm going to call table from now onwards. The best array, or rather it's a matrix, the best matrix, it has how many rows? 1 to n. Maybe it will look like this. So there are 1 to n rows. So this is, let us say, first row, second row, third row, and so on. So there are how many rows? N rows. In our case, 10 rows. There are 10 test scores, right? So this is row number 1, 2, 10. First row, second row. And how many columns are there? In this case, when I'm saying setting k to 2, there are only 2 columns, right? When I'm setting k to 2, I can in fact make this table slightly thinner. There are only 2 rows, 10 rows and 2 columns. So to be able to construct the table in your mind is all that you have to do for a DP, dynamic program problem. Okay, so now I'm saying that, okay, there are 20 entries in this table. One of these entries is corresponding to the optimal solution. So now the entries are what? The entries are defined in this hint, that what are the entries. So now read that hint once again and tell me that which best ij entry is the optimal solution. Pratham is saying that can we do one thing, taking the sum of all marks and based on k removing those marks from the total sum, which leads to better sum of marks. No. So we will lose. What will happen is we will lose continuity. So we have to take a continuous set of scores from where we can drop K. So we lose continuity in Pritham. What Pritham is suggesting is not going to work because the continuity will be lost. So now I'll tell you what needs to be done. So imagine the best segment. So you know that the best thing you could do is if you take the first 7 marks, then you drop this guy. You drop this guy. Oops. Let me take the you drop. Okay. So you drop this guy, this mark, and this mark. So 2 marks have been dropped. You take the first 7, then the best you get is the best sum you get. 6 plus 3 plus 6 minus 1 plus 10, that they have said is 24. So how does the optimal solution look like? The optimal solution is a set of consecutive things, consecutive marks, and it ends somewhere. It ends somewhere. Okay. And it drops at most 2 marks. So in this table, if you see, one of the entries in the second column, okay, so maybe this column is this entry, this is corresponding to the best you could do if you end at the first mark itself while dropping at most 2 other things. This is the best you could do if you dropped at the second mark. This is the best you could do if you ended here. Okay, so you are ending at the 7th position. So there is an entry here in the 7th row, second column, which is 24. That is the description of the best array. This is what the best definition is saying. So there is an entry in the 7th row, second column in the best array, which is corresponding to the optimal solution. So in general, the optimal solution is somewhere in the second column, because the second column is corresponding to ending at one of the spots. The segment ends somewhere and dropping at most 2 marks. Is that understood? So what is the question? The question is, show me this consecutive set of marks where you are allowed to drop at most k scores such that the total marks after dropping is maximized. That is the question. This is the maximum segment that you can get while dropping at most k marks. So to do that, we are going to say that, look, this best ij notation I have used, which is corresponding to this matrix, and these are nothing but some subproblems. From these subproblems, we will construct the solution to the final problem. Inductively, we have to compute, they are saying very clearly, inductively compute best I comma j from something that you have already computed, smaller subproblem, best I j minus 1. Okay, so take some time to understand what has happened. Now I will tell you, or maybe I'll give you some 30 seconds, then I'll tell you how to establish the recurrence, that is the relation between the subproblem and the problems. That is how we will implement this line that I will tell you.
So in the case you have given, the k should be 3, right? Only 7 entries has been considered. So k should be 3, right?
No, what is k? K is how many you are allowed to drop. Okay. So I'm saying I'm setting k to 2. So I'm dropping this and this, nothing else. I'm ending at 10. I'm taking minus 1. I'm not dropping minus 1. I'm ending here. This is the full set of marks. I'm dropping the two most negative marks. I am allowed to drop at most two. That is dictated by the input, where k is 2.
Okay, sir. Okay, got it.
So now I'll tell you how to establish the recurrence. So I think you can also participate in this. This is not too difficult. So first thing is best of 0, 0. This is a base case. See, we have seen the base case previously, that in the segments question we have seen, right? We have seen that if there is only one segment, then how many intersections are there? No intersections. So base case all one is 0. Similarly, we have to establish a base case to start with. So what is best of 0, 0? The maximum segment marks you could get if you consider a segment ending even at 0 position, no position. So best of 0, 0 means
Full marks.
yeah, come again.
Full marks. That is the best, right? 10 out of 10.
No, best of 0, 0 means it denotes. So put 0 here, put 0 here. Let best of 0, 0 denote the maximum segment ending at position 0 with at most 0 marks dropped. So what is the position 0? This is the position 0, the first test. You're not allowed to drop anything. You are at the first position. Then what is the best you could do?
Full marks at 0th position.
No, say read the question once again. So these are the the Lavanya, the person, lady, she has taken the test 10 times. First time she has got 6 only. How can she get full marks? She has got 6 only out of 10. Then she gets -5, then she gets 3, and so on.
We are looking at this data set. Oh, sorry. Sorry.
We are looking at this data set, yes.
Okay.
This is our input. So our input is like this. How many marks? How many were allowed to drop? And what are the marks? Now, best of 0, 0 means you denote best of 0, 0. Yes.
6.
Yes. So you are ending, you are saying that, look, I'm not going to see whatever marks she has got later. I just bother about what she has got initially, and I'm not dropping anything. Then you have best of 0, 0 is equal to, let us say this array is what I'm going to call this array with something. Let's call this array marks array. So best of 0, 0 is nothing but marks 0. Yeah, this is a base case. So I'm defining the base case of the recursion, the base case of the DP recursion, that dynamic program recursion. Okay. So now, what is the best of I and 0? For all I, which is greater than 1, or rather greater than equal to 1, let us say greater than 0, and less than equal to, in this case, it is 9, but let us say I'm going to make it generic. So now I'm defining the recursion. So what is the best segment that ends at I and does not drop anything? Suppose this is I, this 10. So the 7th positions, let us say I6. So if you are looking at all those segments that end at this position, then two things are possible. Either you take the best till the previous position plus whatever marks the person has got in the ith position, or maybe the best so far is negative, so you only take this ith position marks. Some notification. Marks I, total marks up to I. Total marks up to I. No, if you take total marks up to I, that could be negative number. For example, if all these numbers were negative and this was 10, then the total number marks could have been negative. So there are two possibilities. Either you take, so you have to take the better of the two. I'm going to say max of. Either you take the number there at ith position, so marks I, the better of the two, or marks I plus so far whatever you have got, best of I minus 1 0. So the best you could have done if you had taken the best till I minus 1th plus marks I or marks I itself. There are two possibilities only. So this is how we are going to establish a relationship between a sub problem that we have already computed. That is this guy. This guy we have already computed best of I minus 1 0. We are going to write best of I 0 in terms of best of I minus 1 0. This is the crux of the recursion. This is the crux of the DP. What I said, that optimal substructure property.
But sir, we didn't drop any marks
That is
till
the definition. That is the definition of. So see, best of I comma j means at most j marks are to be dropped. So best of I comma 0 means no marks are to be dropped. 0 marks are to be dropped.
So we should add the negative marks also. No, we don't want.
Yes. Either you do that or you take the best. So maybe the marks I itself is what you should take. But if the best of I minus 0 is non-zero, positive, then you take that positive thing plus marks I, then you make more progress than taking marks I alone.
Okay, sir.
Think about it for a minute. So read this definition of best I and read this and think about it for a minute. What has happened?
So you are recursively looking back, like.
Yes.
mm,
So how are you going to write best of I comma j? What changes we have to do here? You want to stop at ith mark. You are allowed to drop at most j marks. So how am I going to write best of I comma j or best ij in terms of the previous rows, best of I minus 1, best of I minus 2, the previous rows? How am I going to write?
The maximum average till that ith point can give the best score.
So if you are stopping at I, so you're definitely taking I. So marks I you are taking plus whatever best you have seen so far. So best of I minus 1, and you have to drop j at most. That is one possibility. The other possibility is that you do not take uh, the other possibility is that so you are allowed to drop at most j. So you are willing to end at I. So marks I you are anyway taking. So maybe marks I itself is the best, right? So it doesn't make difference. So maybe marks I itself is the best. The similar thing. So you're taking marks I. You're allowed to drop at most j things previously. So best of I minus 1 while dropping at most j. So best of I minus 1 j plus marks I. Or you may or may not uh, drop so many things. So let us read this once again. In let best I comma j denote the maximum segment ending at position I with at most j marks dropped. So ending at position I is mandatory. So because ending at position I is mandatory, so marks I has to be taken anyway. But it may happen that if you take marks I, then you don't have to take anything previously. I think this is sufficient. Okay, so I think most of you are not getting what is happening because you're not able to respond the way I'm expecting. So I can write the code, but we have 5 minutes. But writing the code will take some time. So what I will do is I will encourage you to think on this problem because writing the code doesn't help because you have not understood what has happened. You did not understand the recurrence at all. I will copy this question for you. You give it a thought. So tomorrow we will have one more session. I don't want to keep you waiting today further. So tomorrow we have an extra session. So in the first 15 minutes of tomorrow's session, I will write the code, but the recurrence is same. I'll just implement the recurrence. This entire thing I'll copy. I'll paste here in the chat box. Sir, can I talk to you towards the end of the class? Of course, you can talk to me. I will be here. We'll talk, Jayesh. Okay, so this is a question. So towards the beginning of the session tomorrow, 15 minutes. In 15 minutes, we'll implement this. But you have to understand the recurrence that I have shown you, that why this recurrence is correct. Why we can write base I comma j in this way, you have to understand this. Okay. And another thing is, there is a question which Gahan had asked. I had noted it down, so it was corresponding to just a second what he had asked. He's asking that how can we approximate n factorial as n by e to the power n. So this question we will discuss. If you have any questions to ask me in the this thing extra session, there are no protocols or restrictions, so we can discuss anything related to programming or related to algorithms. You can send me an email by preferably by 5 p.m. tomorrow. We will discuss those things at this email ID. Send mail by 5 p.m. tomorrow, and we will discuss. Tomorrow 6 to 8 we will meet again one last time in this course. Okay, so yeah, I think it's 8 o'clock we will conclude for today. And thank you for joining. Tomorrow I'll see you at 6.
Sir, I have one more program. When I searched in Google, I saw this one. This is a nice one. So, can we discuss it tomorrow? Because it will help
Yes, yes.
the
You
people.
can send the program to me by mail.
Here, I know already. I know the answer. But
Oh,
if you
yes, sure.
explain this, it will be helpful to others also, because we didn't go through these sections also. What is error, like that.
Mhm. Okay, okay,
Sir,
fine.
can you explain the previous permutation?
Is the deadline over?
Yes, sir, deadline over.
Yes. So I will write down. So you send me an email, or rather I'll just note it down. So you are looking for previous permutation. So your answer is correct.
Yes, sir, yes, sir. Answer is correct, but I was in doubt.
Previous permutation we'll discuss. We'll discuss this program by Salmabi. We will also discuss approximating n factorial. Jayesh, you wanted to discuss something?
Yes, sir.
Please go ahead.
Can you hear me?
Yes, yes.
So, sir, I'm actually a commerce student, and I took this course up because my friends were taking it up. So, sorry for being so blunt, but I'm actually not at all prepared for the exam. So, can you tell me what important topics I can cover within 2 or 3 days so that I can pass?
It's a very good question. Uh, so your preparedness is very low. That is what I understand.
Yes, sir.
Uh, so have you written any programs in Python before?
Uh, After taking up the course, I did see a few videos on YouTube and I did basic ones. Yeah.
Okay. So were you able to install Python?
Yeah.
Okay. So I would suggest that uh, you go through the assignment questions one by one. There are only few assignment questions in the last 8 weeks. So if I were
Mm-hmm.
in your place, then I would look at all the assignment questions and their solutions once the solutions are published. I think most of the solutions are available to you now.
Yes.
And the solutions that I have provided, the solutions which are corresponding to the assignments in the last offering of this course, if you go through the
Mhm.
assignments, then I think you have a good chance of scoring 50% marks.
Also, sir, do our assignment marks also be included in the 50%?
I'm not saying that. So I'm saying that, yeah,
No, no,
so
I
the
understood
weightage
what you're
wise,
saying, sir. But the assignments that we have written through our computers, is that also included in the total marks?
that's what Salmavi was saying, that 25% weightage is for the assignments and how you have performed in the assignments.
Okay, so 25% there, and if I get another 25% here, it'll be 50.
Yeah, if you have got 25 out of 25, then you are already close to passing.
Okay, I will.
Not like that, sir. For assignment, we need more than 10 marks, and in exam, individually, you need out of 100, 40 marks you need. Only then they will add up these 2 marks.
Okay, then I
Individually,
misunderstood.
you need 40 marks in the exam, and individually in the assignments or quiz, you need 10 marks, more than 10 marks. Then they will add up.
More than 10 marks in the assignments out of how many marks?
25. Out of that, I will check 1 minute.
Okay, so
Okay.
independent of the assignments, 40% marks is expected in the final exam.
Hmm.
Yeah, correct.
So in the assignments, however much, even if you get 100% in the assignments, that is not going to pass you. That's what I understand.
Assignments they are
So,
given out of 25, you need 10, and in exam out of 100, you need 40.
Okay. So in your situation, I would try to understand all the assignments, not only getting the correct answer, but how to get the correct answer. I would try to understand.
For
but
Jayesh,
will
I will
the
tell one trick.
yeah.
First, you should follow all the cues and programming assignments well. So they will change the some numerics and some statements they will change, and they will ask the same pattern. They will ask the questions in the section one, and when you go through your profile, there is one section. Download videos, uh, text
Yeah.
transcripts books, download videos is there, one section is there. Go through
Yeah.
download videos, so you will go to another window. That's the
Mm-hmm.
previous section is there, downloads. One NPTEL window will be open. There is one section assignments, transcripts, books and videos. There is they given the previous assignments. So there will
Okay.
be previous assignments not related to our current assignments. So you can
Mm-hmm.
go through for follow that also. The solution they are given. So you can look at that also. So you will get the pass mark, I think.
Also, so do you have any idea if the paper will actually be difficult or will it be easy?
I have no clue.
You don't know who's setting the paper?
No, I don't know anybody in NPTEL except one person who is my contact. And uh, I mean, I'm independent of NPTEL. My responsibility is only holding the problem solving sessions.
Okay. But have you at least like seen previous papers or anything?
No,
No idea. Okay, do you expect it to be easy or difficult?
I am not able to expect anything because I have no data.
Okay.
Plus, what is difficult, what is easy is a relative thing.
So because one thing I understood was the videos that we had and the assignments we had were barely even close to similar. The videos explained some other topic and the assignments were a total different topic.
So you're saying that the assignments are not in line with the topics explained in the videos?
Correct.
I will disagree. I think uh, you know the assignments have to be designed in such a way so that you have to use your uh, you know you have to think, you have to use your brains to be able to answer the question, so it cannot be straightforward directly from the videos. But I think there was enough material in the videos that you could solve the assignments by looking at the videos, or by attending the sessions that we conducted.
Okay.
So for you, yeah, just go through the assignments. That is my uh, short advice.
Or is there any specific lecture do you want me to go through,
No,
or
no,
any specific week 1, 2, 3?
no, no, I'm not in the. I'm not able to answer that question. I don't know. I don't know the answer to that question because I do not know who is setting the paper and how the paper will be set. What weightages will be distributed over the different weeks.
Okay, then Salambi, if I'm not wrong, what was the name of the person who spoke before you?
Salmavi.
Salmabi,
Yes, sir.
are you also a student?
No, I didn't return any NPTEL. This my first one, but I go through the YouTube and Google. They given the past participants, the students given their experience and some of the questions they are given. So from that, I only get this information.
Okay. Would it be possible for you to share that information with me?
One question I shared here, and most of the questions they shared from quiz, only that I know.
Okay, so one more question. Is the whole paper going to be MCQ or is there descriptive type questions
They
as
are
well?
telling that MCQ, fill in the blanks, and numeric in the quiz we are writing the list, numeric values we are given, like that they are saying, telling, and some program snippets they will given. We should tell them what is the error, like that they are telling.
Do you know the weightage distribution? How many marks is MCQ? How many marks is this?
That I don't know.
Okay. Okay. Thank you so much.
All right, thank you. So is there any other queries? All right, so I'll see you one last time again tomorrow, 6 to 8 p.m.
Thank you so much.
Sir, can tomorrow
Thank you.
you explain previous permutation, sir?
Yes, yes, I have noted that down.
Oh, thank you, sir.
Thank you for joining. See you. Good night.
Good night, sir.